to provide protection at the new higher burnups that we were witnessing in the United States. Another is fire-induced cable shorts. Fires are really, as most of you know, problematic, and in electrical equipment, the problem is they turn things on that you didn't want turned on, and they turn things off that you wanted to stay on. So they're very unpredictable in how they affect the plant. And there was a lack of common understanding in the industry and at the NRC as to how to analyze and protect cables from this type of damage, as well as some of the fire protection materials themselves didn't perform as well as expected. But there was no regulatory change required. What resulted was really better implementation of the existing regulations. But this only works as well as it did because of safety culture within the industry. That as a result of testing and a better understanding of fire-induced cable failures, we updated guidance, which is a way we explain how to meet the regulations, but is not itself guidance. And it began to bring into common use in the industry fire PRAs, which helped the licensees understand what changes they could make to their facility to better protect against the problem. The third example is the AP 1000 shield building structural design. As mentioned, when they came in with Rev 18, or Rev 16 initially, it ended up being certified as Rev 19. It brought in for aircraft protection regions the steel concrete composite design approach, which is steel, instead of the steel rebar internal to the concrete, its primary reinforcement is the form of plate on the outside of the concrete. It was really the first time it had been used in this type of safety critical structure anywhere in the world, and certainly to the extent it was. And in 2009, we were unable to resolve our safety concerns with Westinghouse. We informed Westinghouse in writing that we would not accept the design as proposed, and they had to change it in order to get the revised design certified. So Westinghouse went through a reanalysis, redesign. The principal issue with the composite methodology itself was that there was no connection between the inner and outer reinforcement, and it didn't behave as a unit, and we thought it could fail under a design basic seismic event. And this building has a very important safety function. It supports that large water tank you saw earlier, but the collapse of the structure would also probably collapse the containment within it and severely damage all the systems. We felt it was a very important safety issue. So Westinghouse went through a redesign process, and they came in with what they called the enhanced shield building, which had a lot of changes, but the ones central to this issue was that they added transverse reinforcement as well as thickened the plating on the outside. However, within the staff, we could not get a consensus as to whether or not the revisions were sufficient. And it was hard to get consensus because there is no consensus standard on how to do this. We were trying to use American Concrete Institute standard 349, which is for reinforced concrete, but it isn't for steel concrete composite. So we couldn't get an agreement among our own staff as to whether or not that was a safe design. As a result, we got a non-concurrence filed by the lead structural engineer for the review, an internationally recognized concrete expert, Dr. John Ma, and it was a very public non-concurrence as a result, but we did ultimately decide that the design was safe. We aired the concern. We never reached consensus with Dr. Ma that we had made the right decision, but we had independent reviews by our Office of Research as well as the Advisory Committee on Reactor Safeguards, and we're confident that that design is very safe. But the NRC has already certified 4 designs, the AP 600, the ABWR, the CE System 80 Plus, and the earlier AP 1000 design. And the rulemakings for those certifications, we got under 10 comments on any one design. In fact, I think the highest number was 3. On the AP 1000 current proposed rulemaking, we received over 13,500 comments. Most of those comments deal with 2 issues. Don't certify until you've resolved Fukushima, and the shield building is going to fall down. So this is where we don't have to do what the public wants. We want them to understand the rationale for what we've done. So we will respond to those comments, not all 13,500 individually, but 13,500 collectively. So with respect to the shield building design, we remain convinced it was adequate. No one's raised a new issue that we were unaware. with respect to Fukushima for both AP1000 and the ESPWR, that based on the near-term task force review, that those designs already address the bulk of what we expect to come out of the Fukushima review, and so we can proceed with those. If we later find out, in fact, that there's something they need to do, we have the regulatory vehicle to impose it. So again, this is internal safety culture working, but our independence and openness also came into play. How am I doing on time? Okay. So I'll do, I got 2 more examples, and I'll try to be brief on the one which is digital INC, which I could spend the rest of the afternoon on. The agency has struggled greatly with digital INC on the new reactor reviews in particular, and it's not that we haven't licensed digital. We have, for over 30 years, licensed digital INC, but the new designs, some of the newer designs, are fully integrated INC systems, and they bring it in a way that wasn't anticipated. And basically, our regulations don't address digital. They've never been updated for digital. The regulations that specifically apply to INC are contained in the general design criteria written in the late 60s. So, but they still work, amazingly enough. And they have 4 principles in those, which are independence within the, and that's a different kind of independence. It's independence between the safety channels and independence of the safety system and the non-safety system, redundancy within the system, defense in depth, and diversity. But it's turned out in digital INC, there's a 5th principle that's come to play, but it isn't a regulation, that is simplicity. It isn't that you can't have a complex INC design. What we're finding is that the applicants can't explain how a complex design works in a way that satisfies our regulatory requirements. Typically, what we're finding is that the data communications can't be shown to be independent either across the safety channels or between the safety and non-safety systems. And that's a bigger problem when they're relying on software to provide that protection, because under Part 52, we typically do not have a completed design. We have it's not a conceptual design, but they haven't finished it. And so they typically haven't written the software that they need to show that they've got independence and redundancy. So as a result, we're not able to complete the reviews in the time frame that they need to meet their licensing schedule, and so they're being forced to simplify the designs. And to give you a quick example of simplification is, in one of the designs they have what they call a prioritization module. This prioritization module's role is simply to determine of all the things it needs to do based on the inputs it's getting is which does it need to do first. The original system design had so many inputs that in order to fully test all the inputs that you knew that it would give a predictable output, required 2 times 10 to the 18th tests. Now I did some quick math, and even if you could do 1,000,000 tests per second, it would take you 30,000 years to do all the tests. I don't think that's an acceptable schedule to anyone. When they simplified the design, they came up with a design that required 512 tests. You can do 512 tests. That's why I say it's not a requirement, but it sure makes licensing the design much, much easier. And the last example I'll use is there's been so much focus on Fukushima here and really for the past 7 months almost. But the last big event that changed the NRC's regulatory framework, potentially even more than is going to happen after Fukushima, wasn't even a nuclear event. It was 9/11. Right? That didn't even involve nuclear power plants other than theory. But when you look at what we did post 9/11, we in industry, and again, give credit to industry or safety culture, is they did not wait for the NRC to fix its regulatory framework before they began taking actions to better protect their plants. But the fixes done post 9/11 were involved everything, legislative changes, regulatory changes, as well as safety culture. We increased the security force capabilities. We changed our access and authorization requirements. We even have access authorization requirements for units under construction that are unprecedented in U.S. industry. We strengthened security force training and qualification programs. We issued regulations for all units regarding loss of large areas due to fires and explosions. And for new reactors, a specific requirement that they address aircraft impact either through design to prevent penetration of the containment or they have mitigating systems in the event there is penetration. I will say all the new reactor designs that have come in have taken the path of no penetration. And then we've greatly enhanced our coordination with other federal agencies with regard to emergency preparedness. Now, even though Fukushima doesn't cause a loss of large area due to fire or explosion, the strategies that the industry went through in response to 9/11 made our quick look after Fukushima much better, because it's still a loss of a large area. So they had already done things like pre-position additional equipment close by, but not in the immediate vicinity of the plant. Where Fukushima may require changes, yeah, they have a backup diesel generator powering a pump 1,000 feet off the site, but it's at the same elevation as the site. So as a result of Fukushima, they may need to elevate it 40 feet, depending on the flooding risk at the site. So that effort from 9/11 actually paid off currently under our post-Fukushima response. So to wrap it up, I'm just going to get to conclusions. Again, that applying the principles of effective regulation and promoting a positive safety culture, we think leads to positive results not only in the way we regulate, but in safety of the industry as a whole and how the public is protected. That our communications with licensees and applicants to resolve issues results in significant safety enhancements. And then ensuring reliability in both NRC regulations and guidance promote the public health and safety in the United States and around the world. Thank you.